So what is the factory pattern? Well, basically by definition, you would use the factory pattern whenever you would want a method to return one of several possible classes that share a common superclass. So in my Java video tutorial, I created a video game. So let's say I wanted to shoot an enemy onto the screen at random. Well, if everything's hard-coded and I don't know what type of enemy that's going to go onto the screen, using basic programming techniques, that makes it very hard. However, let's say that I create a random number generator and each potential enemy class is assigned one of the numbers that could pop out of that random number generator. I could then send that number to the factory object and it will return for me a dynamically created enemy and throw it on the screen. So it's very important. The whole main concept here is we want the capability to have classes chosen at runtime, and that's what the factory pattern provides for us. So when would you use the factory pattern? When you don't know ahead of time what class object you might need. However, there's a caveat to that. Make sure that all the potential classes are of the same subclass hierarchy, which means somewhere up the list they all have the same superclass. You would also use a factory pattern to centralize class selection code when you don't want the user to have to know every single potential subclass. And of course, like always, to encapsulate object creation, which is always great. And here is a UML diagram that explains the basic layout or creation of a factory pattern. You're going to have the client, which is the user, the main program, and it's going to call the factory object and say, hey, make me an enemy ship. And here we're providing a string instead of a random number, and it's going to go over here to the abstract class called enemy ship, and it's going to implement all of the common different methods that we would need for any enemy that we would use in our video game. Then from that, we're going to create UFO enemy ship and rocket enemy ship that are all going to implement this abstract enemy ship class. And just to reinforce this, the factory pattern allows you to create objects without specifying the exact class of an object that will be created at runtime. So let's get into the code and explain this further. Now, all the code in this tutorial is available in a link underneath the video, just like always. It's heavily commented to help you learn this stuff. Well, the first thing we're going to create, of course, is the enemy ship class. And I'm going to go the whole way through this so that you completely get it and understand why you would need the factory pattern. So here is enemy ship, and it's going to have a couple private fields such as name, double the amount of damage it could entail on our hero, and then public string get name, which is going to return the name for our enemy ship, public void set name, which is going to receive name for our ship, equal to new name, and then we're going to do exactly the same thing. Make sure I capitalize that. There we are. And then we're also going to do the same thing for damage. Return amount of damage that it does, and then set damage, and it will be a double, new damage, amount of damage, and set that to double. Okay, so that provides me access to those different fields. And then we're going to come in and go public, figure out all the different things that all of our enemy ships are going to have in common. Well, one thing is we would like to have code that automatically just makes it go out there and follow the hero ship, because that's something that every single enemy is going to want to do. Just go get name is following the hero. And then basically we're going to have two more methods that are going to do pretty much exactly the same sort of thing here. What's something else we would want to do? Well, we would want to display the enemy ship. We're just going to say is on the screen. Enemy ship, and our enemy ship is definitely going to shoot, and we're going to say attacks and does get damage. There we are. So all of our enemy ships are going to do all three of those different things. So now that we have this abstract class enemy ship created, now we're going to create UFO enemy ship, and this is going to be very simple. We're just going to go public class UFO enemy ship extends enemy ship. And for this tutorial, we're going to keep this quite simple. We're just going to create ourselves constructor, set name, UFO enemy ship, set damage, and let's say that it does 20 damage. So real simple. Now that we got that created, we can go into rocket enemy ship, do pretty much the same exact thing. Of course, got to change this to rocket. And our rocket is going to be a little bit faster, but it's not going to do as much damage. Breaking everything down into that. And then we're going to jump into enemy ship testing. And we're going to look at this from multiple different angles so that you can understand why the factory pattern is used. So I'm going to allow the user to come in here and pick their ship at runtime. So we're going to need scanner to monitor keyboard input. Enemy ship testing. And this is the main program. So public static void main is needed here if we want to run this guy. There we go. So what are we going to do inside of main? Well, let's approach this using the old way of creating objects, and you're going to see exactly why the factory pattern is going to be very nice. We're going to create a new UFO ship because that's the only way to use it if we're just simply using inheritance. So we're going to go like this. So there's our UFO ship, and then we can say we want our enemy ship to do stuff with the UFO ship object that we just created. And of course we have to create do stuff. Public static void do stuff enemy, and it's going to receive our object, our enemy ship, an enemy ship. And then what are we going to have it do? We're going to have it display the enemy ship, of course, because if it's not on a screen, it's not worth much. And then we're also going to have it follow the hero. And then if it's going to follow the hero, it's also going to want to shoot at the hero. And there you go. So this is our old style way of implementing this sort of stuff. And it kind of stinks, but it does work. See, there's UFO, enemy ship's on the screen, it's following the hero, and then it attacks and does 20 damage, okay? Well, of course, you can see why that's not any good, because it's not dynamic. So we're going to come in here and just using inheritance, see what we get. So I'm going to go scanner, user input. This is going to allow the user at runtime to define exactly what type of enemy ship to put on our screen. So at least it's going to be dynamic, we know that, and that's good. So string, enemy ship, option, system out, and then we're going to say what type of ship, and we're going to go U or R. If user input, and we're going to say has next line, because they're going to be giving us a string. Just so you know, I want to reinforce the fact that this has nothing to do with the factory pattern. It is more about why you need the factory pattern, because I want you to be able to spot that whenever you're writing code. And you go, oh, wait a minute, I'm doing this bad thing I shouldn't be doing. I should use the factory pattern. Then we're going to go next line, which is going to read that string there and assign it to enemy ship option. And then what we're going to need to do is, this is a big sign that the pattern is needed. We're going to go enemy ship option. Now, since we have two potential options here, we're going to have to put in a bunch of if statements. So we're going to go the enemy is equal to new UFO enemy ship, like that. I'm going to get rid of that and just type in the enemy. Give it a value of null. So here we're going to create that class dynamically, and then we'll go else, and then basically the same exact thing. R is the other option, and then we're going to send do stuff the enemy, and we'll run this now. And you can see what type of ship, and let's type in R, and you can see the wrong thing popped up, and the reason why is I forgot to go rocket. Let's file save it, execute it again, R, and there you can see rocket enemy ship is on the screen. So that's dynamic. However, it doesn't close the code from being modified, and that is bad. So you don't want this sort of stuff to be going on inside of your actual program. Tons of if then else statements, and then making all sorts of changes based off of that. So now I'm going to show you how to do all this using the factory pattern. So let's just go in, delete all this bad stuff. And I'm going to over here jump first just to make a point, and create a subclass of the UFO enemy ship and call it big UFO enemy ship. And I'm just going to jump in here, copy that, jump over into this, paste it, and this is going to be big. So let's say this is like a boss or something like that. Big, and it does 40 damage, and this is just big. So this is going to be a subclass of UFO enemy ship, just to show you that that can indeed work. And then we're going to jump over into enemy ship factory.java and show you exactly what is so factory about this factory. So we're going to go public class, and I'm going to call this enemy ship factory. Basically what we're going to do is we're going to take all that decision making and move it totally out into another class. We're going to go public enemy ship. That's what it's going to receive, and we're going to say make enemy ship. And we're going to be provided both a string just like before, and we're going to go enemy ship new ship is equal to null, and then we're going to put our if statements inside of there. So we're going to go new ship type equals, and let's say they sent us a U, and yes, I know they could put a lowercase one in there and that would mess everything up, but I'm just trying to keep this simple. So it's going to return in that situation a UFO enemy ship. This is going to completely encapsulate ship creation, so that whenever we have to modify something, there's only one place where we're going to have to make those modifications. Else, and we're basically going to do the same thing. And we're going to go R, and if they give us an R, we're going to change this to rocket. Else, if they send us a B, we're going to give them a big UFO enemy ship. And else, we're going to return null. And there you are. You just created yourself a factory. So now let's try out that factory. We're going to jump back into enemy ship testing. And now we're going to create our factory object. So it's going to be enemy ship factory. And I'm going to call it ship factory is equal to new There we are. So we just created that guy. Create a new enemy ship, the enemy, give it a value of null, and then we're going to still use the scanner. What type of ship, just like before, except this time we're going to say they can enter a U, an R, or a B if user input as next line. I get that string, and I'm going to call it a string, type of ship, and that's going to be equal to user input. Get my string and save it. Then I'm going to go the enemy is equal to ship factory, that object that we just created above, and then we're going to call the method make enemy ship and pass it the code that is going to be tied to the class that needs to be created. And then, of course, I don't need that. There's that. And then we're just going to check to make sure enemy has a value, not equal to null. And then if it works out for us, we're going to throw that inside of there. And then otherwise, we'll say else and give them a little bit of a warning next time. There we are. So let's try out the factory and see what happens. So there we are. What type? Let's just say B, enter. There you go. Big UFO enemy ship. And everything's created dynamically using the enemy ship.java factory object. So that is the beginning of using factory patterns. And up next, I'm going to cover the abstract factory pattern as well as